Hey guys, welcome to the channel. So today we'll be doing the AS level physics chapter 1, physical quantities and units. Okay, so this is a very short chapter and it's pretty easy to understand. Okay, so first we'll be looking at the units. Okay, so first we have tera. Okay, tera is 10 raised to 12, giga is 10 raised to 9, mega is 10 raised to 6, and so on. Okay, so we have kilo, deci, centi, milli, micro, nano, and pico. Okay, so basically how this works is, suppose we have meters. Okay, meters is just 10 raised to 1, and above meters the next big thing is kilometers, right? So kilometers is going to be 10 raised to 3. Okay, like for example, if you want to turn meters small to big, right, meters to kilometers, we're going to do divided by 10 raised to 3 or divided by 10 divided by 1000, right? So in the similar way, you're going to have your unit here, and these are basically powers that you're going to add in order to convert it to those respective units. So if you want to turn meters to megameters, you're going to do 10 raised to 6. You're going to divide it by 10 raised to 6. If you want to turn meters to centimeters, you're going to multiply by 100. Okay, so that's it for the units. Okay, it's very important to memorize these because it usually comes up in the MCQs. Now the next thing we're going to learn about is the SI base units. Okay, so SI base units. So I think there are 7 of these. Okay, and it's very important to learn these. Again, they come up a lot in the MCQs. Okay, so let's start. The first SI base unit you need to know is mass. Okay, mass is an SI base unit, and the unit is kg. Number 2, we have length, and the unit is in meters. Okay, meters. Thirdly, we have time, which is in seconds. Then we have current, which is in amps. Okay, it's written as, it's just an A. Okay, this is seconds. Okay, number 5 is temperature. Temperature is always in Kelvin. Okay, it's not in degrees Celsius, it's always in Kelvin with a capital K. Sixth one is amount of substance, which those of you who do chemistry would know is moles. Okay, so there are 6 SI base units, right? 1 2 3 4 5 6. Yep. So you guys need to know the base and their units. Okay, it's very important to learn this. And the next thing we're going to learn about is percentage uncertainties, and these usually come up in calculations. Okay, but before that, let's just look at the random errors. Okay, this is part of this chapter where we basically talk about errors that might come in different experiments. Okay, so random errors may be, suppose you don't, if you're measuring something, suppose you have a pencil. Okay, you have a pencil. Okay, and you want to measure the length of this. Okay, so you're going to keep a scale, and you're going to, this is the scale and this is your pencil. Oops. Okay, so suppose you want to look at the length of this. Okay, so instead of taking this length, if you by mistake took this length, then that's a random error. Okay, or another thing maybe that maybe you didn't start from 0. Okay, you kept the scale here, right? So the 0 starts here, so your measurement is going to be wrong. So that's like an example of random errors. So how do you reduce this? Okay, how to reduce random errors, that's what we're going to look at next. And this usually comes up in your practicals. Okay, so how do you reduce it? Number 1, you calibrate your apparatus accurately. Okay, calibrate apparatus accurately. So what does that mean? Sometimes when you buy a scale, it may not be the actual measurements. Okay, the numbers may be wrong. So if you buy an unknown brand scale, you might have, suppose this is like a known brand. Let's say this is a Faber-Castell scale. Okay, so there's 1 2 3 4 5 6. Okay, and you have a 0. But suppose you get like a random scale, okay, from like an unknown brand. Their measurements might have 1 here and the next 2 might be here. Okay, and this means that it's wrongly calibrated. Okay, so the whole meaning of calibrated is like, is the readings, where these readings are kept. Okay, so the first way to reduce random errors is to calibrate your apparatus accurately. Number two is, sometimes we have experiments with radiation involved. Okay, so if radiation involved, you need to take account the background radiation. Okay, the background radiation. Okay, this is very important and people all often forget about this. Okay, so number one is calibrate apparatus accurately, and number two is, if radiation is involved, take account of the background radiation. Okay, so for those of you who don't know what background radiation is, you might have learned this in your GCSEs, but in Earth, okay, if this is the Earth, it already has some amount of radiation being emitted from it. Okay, so when you talk about rocks, even rocks, stones, soil, everything emits radiation, and that's what you call background radiation. Okay, so whenever you're going to do an experiment with radiation involved, you always need to take account of the background radiation. All right, and the third and the last one is read the lower meniscus at eye level to reduce parallax error. Okay, lower meniscus to reduce parallax error. So what does this mean? So suppose you have a measuring cylinder. Okay, this is a measuring cylinder, you have your readings here. Okay, and you have some amount of water. Okay, so this is somewhat what the water would look like. Okay, so if you're going to look at this with your eye, you need to make sure that you're keeping your eye at the same level of the lower meniscus. Okay, lower meniscus is basically this. Okay, so this is what the water looks like, and this part is the lower meniscus. Okay, so you need to get the lower meniscus to your eye level. Okay, so like you can see here, this is not at eye level, so here. Okay, so the reading here would be, for example, if this is 5 and 4, this would be 4. Okay, so lower meniscus to reduce parallax error. That's why you read any measurements with that involves a measuring cylinder with. Okay.